Okay, this is a review for the section on functions, even, odd, and graphing parent functions. Complete the following graph to make the function odd. Odd means opposite. So if you look at this green dot right here, that's left 3 up 4. The opposite of left 3 up 4 is right 3 down 4. So let's put that point right here. And then I've got the blue line, then the opposite of that. So this top point is up 3, so if I go down 3 and draw a circle there, and then to the left 3, opposite of that would be to the right 3, connect those dots, and then this orange line is what, left 4 up 2, right 4 down 2 is the opposite of that, and then that other point is what, left 8 up 4, so right 8 down 4 would be right here, and that looks like this. So this is the opposite, that is the odd function there. And then on the right, complete to make this function even. To make this function even means it's going to look the same on both sides. And so if I look at that, 1, 2, 3, 1, 2, 3, like that. And then if I go to the other side, negative 4 up 2 right here, and then at negative 8, I see right here, that makes this an even function. It looks the same on both sides. Then I'm going to give you a few graphs, classify if they are even or odd. Even, odd, or neither. So if you look at this one right here, the first one, this function is even. Next function B is odd. Function C, that is neither even nor odd. Looks at function D, it's symmetrical. So this function is even. If you look at E, this is an odd function. And you look at F, and this one is neither. You might see questions that give you a point on a graph and ask you what would be there if it was even. So even means the same. So if I look at 7, negative 4, if this were even function, I could go to negative 7, and I still get that same value of negative 4. That makes it even. If it were odd function, when I go to negative 7, I don't get negative 4. I get the opposite of negative 4 on the graph. Determine if this function is even, odd, or neither. Okay, so in this case, f of x is equal to 1 over x. And then I'm going to substitute in and say, well, what is f of negative x? So f of negative x is 1 over negative x, which is just minus 1 over x. So f of negative x equal minus 1 over x. This function is not even. So is it even? No. It is even because f of x, not even because f of x does not equal f of minus x. Now, is it odd? If I ask myself if it's odd, f of x is equal to 1 over x. What is minus f of x? That's minus 1 over x. Now I see that these two things match. So yes, this is an odd function. It is odd because f of minus x is equal to minus f of x. Graphing functions, okay, this is based on x squared. So the parent function here is going to look like x squared. But what has happened to it? That minus 2 means that that vertex has moved to the right 2 and then down 1. So to the right 2 and down 1. And then when I start to graph that, I'm going to see a graph that looks like this. The square root of x minus 3 plus 2. Parent function here is the square root of x. Okay, so what has happened? That minus 3 means that it's moved to the right 3, 1, 2, 3, and up 2. So I'm going to start that function here. So that's what it looks like to have square root of x minus 3 plus 2. X minus 1 cubed plus 3. That's based on the parent function of x cubed, which looks about like this. So this minus 1 means it is moved to the right 1 and up 3. So 1, 1, 2, 3. So that's going to be the origin point here. And so what you see here in this graph is it does something like this. x minus 1 to the 2/3 plus 2. So this is going to be the graph of x to the 2/3. It has moved to the right 1 and up 2. So I'm going to plot this graph right here. So that is x minus 1 to the 2/3. Now I give you an equation and you come back and give me the graph. So it looks like the vertex, excuse me, the inflection point is right there. What is this function? This is based on x to the 1/3. So remember, x to the 1/3 looks like this. Okay, so what has happened, it looks like we've been reflected about the x-axis. So this equation is minus x. So it looks like that vertex moved 1, 2, 3 to the right. And it looks like it moved 1, 2, 3, 4, up 4. So x minus 3 to the 1/3 plus 4. What is the domain of this function? This function has a domain of negative infinity to infinity. This function has a range of negative infinity to infinity. Where is f of x decreasing? And this function is always decreasing, so it is never increasing. So there are no intervals. No intervals where this thing is increasing. It is always decreasing. Next one, I look at a graph and also come back with this equation. That's based on the absolute value of x. Okay, that's what this function is based on. So what has happened to it? It looks like it has moved to the right 3. So the absolute value of x minus 3. And it looks like it moved up 4. And what is the domain of this function? Negative infinity to infinity. And what is the range of this function? The range is 4 to infinity. Intervals where this function is increasing. As I travel from left to right, it is decreasing until I get to that point, and then from there on it starts increasing. So it is increasing from 3 to infinity. Now I give you an equation and ask you some things about it. I've got f of x equal the absolute value, excuse me, square root of x plus 5 minus 4. What would happen if I were to move this function 2 units to the left? Okay, to move something to the left, remember, to move something to the left, I'm going to be adding 2, and I'm going to move it up 1. So I'm going to add 1. So this turns out the new function would be f of x equal the square root of x plus 7 minus 3. Give the equation of an absolute value function. So I've got something that's based on the absolute value of x, okay? And I'm saying that my function has been, it's reflected about the x-axis, that gives me a minus sign. It is shifted to the right by 1. So if it's shifted to the right, that is a minus 1. So shifting to the right by 1 and up 1 plus 1. So f of x is minus the absolute value of x minus 1 plus 1. I give you a function g of x, and let's write f of x, which is reflected about the x-axis. So f of x is, if I reflect this about the x-axis, so it's going to have a minus sign, okay, and I've got x plus 7 to the 2/3. And what would happen if I moved it to the left 4? So moving it to the left 4, that's going to add 4 to this, and moving it down 2. Okay, so what I'm going to get here is f of x equal minus x plus 11 to the 2/3 minus 2. So that takes that original equation, moves it to the left 4, that's plus 4, and then down 2 moves the function down 2 units. Okay, that's it for a review of some of those topics. I do have some extra problems as well. Let's work through. So you can make sure you get as many as you want. Determine if this function is even, odd, or neither. Okay, so in order to do that, f of x is equal to x to the fourth minus 5x squared. F of minus x is equal to minus x to the fourth minus 5 minus x squared. Well, minus x to the fourth, that's minus x, minus x, minus x, minus x, 4 of them. So this tells me that f of minus x is the same as x to the fourth minus 5, and then minus x squared, that's the same as x squared. So what I see here is, here's f of x, here's f of negative x, they are equal. So this function is even. Why is it even? It is even because f of x equal f of minus x. If the point -7, -9 is on the graph, what must be there if it's even? If it's even, I go to the opposite x value and I should get the same y value back. If that function is odd, I can go to the opposite x value, and instead of getting the same y value back, I get the opposite y value. Is the function even, odd, or neither? F of x equal x cubed minus 5x. So let's figure out f of minus x is equal to minus x cubed minus 5 minus x. So 3, negative x times negative x times negative x. So this gives me f of negative x is negative x cubed plus 5x. Okay, these two things do not match. Now let's look and see what negative f of x is. If f of x is equal to x cubed minus 5x, minus f of x is minus x cubed plus 5x. Okay, so what I see here is f of minus x equals minus f of x. So this is an odd function. Why is it odd? It is odd because f of minus x equal minus f of x. Is this function even, odd, or neither? So here is f of x. Let's substitute f of minus x is minus 2 minus x to the fourth minus 5 times minus x. So this gives me minus 2x to the fourth plus 5x. So I look and see f of x and f of minus x do not match. Now let's find minus f of x. So if f of x is equal to minus 2x to the fourth minus 5x, minus f of x is 2x to the fourth plus 5x. So now what I see is none of these match. So this is neither even nor odd. Why is that? Because we have shown that f of x does not equal f of minus x, and it also does not equal minus f of x. So this is neither even nor odd. Look at the graph of cube root of x plus 5 minus 2 with a negative sign in front. So this is based on cube root of x, which is the function that looks like this, okay? So what has happened to ours? It looks like the inflection point right there has been moved, 5 to the left, so 5 to the left and down 2. So there is my reflection point, and it looks like it's been reflected about the x-axis. So what this function is going to be doing is something like this. So what is the domain? Negative infinity to infinity. What is the range? Negative infinity to infinity. Interval of increase. This function is always decreasing. So there are no or none for interval of increase, interval of decrease, minus infinity to infinity. This is based on the graph of the square root of x. Okay, what has happened? It's been reflected about the x-axis. That endpoint has moved 2 to the right. So if I go 2 to the right and up 1, so 2 to the right and up 1, and reflected about the x-axis. So it's going to look like this. Okay, what is the domain? The domain is 2 to infinity. What is the range? That's negative infinity up to positive 1. Interval of increase. This thing is always decreasing, so there are no intervals of increase, and it decreases from 2 to infinity. Negative absolute value of x plus 1 plus 5. This is based on my function absolute value of x. What's happened? It's been reflected about the x-axis. Okay, that plus 1 means it's moved to the left 1 and up 5. Left 1 up 5 is right here, and it's been inverted. So that's the graph that I'm looking for. What is its domain? Negative infinity to infinity. What is its range? Negative infinity up to 5. Interval of increase. As I travel from left to right, this thing increases from negative infinity all the way to negative 1, and then it decreases from negative 1 to infinity. This is based on the graph of x squared, and what has happened to it? It has moved to the left 3 and down 4. Left 3 and down 4 is right here. It has not been reflected, so it goes up. Okay, its domain is negative infinity to infinity. Its range is negative 4 to infinity. Intervals of increase. It looks like it's increasing from negative 3 to infinity. It is decreasing from negative infinity to negative 3. X minus 4 cubed, negative minus 1. This is based on my graph of x cubed. So what has happened to it? That minus 4 means it has moved to the right 4 and down 1. So there's my inflection point. It's been reflected about the x-axis, so what's going to happen to this one is it's going to look like this. So what is its domain? Negative infinity to infinity. Same range. Interval of increase. This thing is always decreasing. So as I travel from left to right, that graph is always going down. Negative x to the 2/3 plus 2. This is based on our graph of x to the 2/3. Okay, so what is happening here? This goes from negative infinity to infinity as a domain, but let me graph it first. So negative 3, that means it has moved to the right 3, to the right 3 and up 2, and it has been reflected. So instead of going up, it's going to go down. So something like this. And so the domain negative infinity to infinity, the range is negative infinity up to positive 2. Increase, it increases from negative infinity all the way over to 3, and it decreases from 3 to infinity. And now I'm going to read you information about an equation and ask you about a transformation. What would happen if I move this function 5 to the left and 8 down? So f of x, back up, is equal to x plus 3 squared minus 2. Okay, to move it 5 units to the left, that's going to be plus 5. And to move it down 8 units, that's minus 8. So my new function is going to be x plus 8 squared minus 10. And that should be it.